Hello and welcome to OnLogic Live. My name is Darek Fanton. I'm the Communications Manager here at OnLogic, coming to you live from OnLogic's global headquarters here in South Burlington, Vermont. Today I have the pleasure of being joined by OnLogic Product Manager Mike Walsh and Travis Cox, Chief Technology Evangelist at Inductive Automation, to talk about the growth, capabilities, and applications for industrial Raspberry Pi solutions. A couple of weeks ago, Mike, Travis, and I got together for a conversation that we'll be sharing with you shortly. Following that, Mike and Travis will join me to answer your questions live, so make sure to drop those into the comments wherever you're watching today's event, and we'll get to as many as we can. You can also join the conversation over on Twitter using the hashtag OnLogicLive. So, without further ado, here's my session with Mike and Travis.
Mike, Travis, thank you both so much for joining me today. For anyone who may not be familiar with either of you or the organizations you work for, give us a quick introduction to yourself. Mike, go ahead and kick us off.
Hey, thanks for having us today, Darek. So I'm Mike Walsh. I'm a Senior Product Manager here at OnLogic. And for those who aren't familiar with OnLogic, we do computers for tough use cases out at the edge. We'll talk today about industrial, manufacturing, some energy. But man, we're seeing applications in smart cities, smart buildings, smart agriculture. It's really about getting intelligence and computers out to the edge.
Awesome. Thank you. Travis.
Yeah, thanks, Darek, for having us. So I'm Travis Cox. I'm the Chief Technology Evangelist for Inductive Automation. In Inductive Automation, we are a software company. We provide an industrial application platform to build any kind of industrial application. It falls in the category of like HMI, SCADA, MES, IIoT, but there's no limits. You can build any kind of application out there. Excited to be here.
Awesome, and thank you so much for joining us. Should be a fun conversation today about industrial Raspberry Pi. So, Mike, give us some context here, set the stage. Before we dive in deep about what Raspberry Pi can do, what led us to develop an industrial Raspberry Pi product?
It's a great question. And it's about the edge, Darek. It really is. So much is happening at the edge today. Data is becoming more and more valuable. And the cost of acquiring that data is coming down so much that we're at this amazing tipping point. It's completely changing industries. When we did the factor using the ARM, we're able to hit that low cost parameter that we need to hit, but also low power consumption and a small size, because you can put them almost anywhere. And that's a key thing for a lot of these use cases, right? But then we took it the additional step and we industrialized it. So dust, dirt, humidity, temperature extremes, all those kinds of things, vibration and shock in these tough use cases, that made the factor 201 and 202 deployable. So it's really that full picture that gets me really excited, right? It's capabilities to cost ratio is just off the hook. And then it's small enough to put anywhere. And that really starts opening up more opportunities, collect data and get value out of that data. And I'm really excited because of our work with Ignition. So we've got two special versions of our factors. We've got the IGN 800 and the IGN 802, which are already preloaded, ready to go with Ignition.
Right, that's so cool. And I know, Travis, for your part, the Ignition community, the industrial automation Ignition community has been, sort of playing around with Raspberry Pi for a while now. Can you talk a little bit about, what sort of things they've been doing from a proof of concept standpoint?
Yeah, absolutely. I mean, there are definitely some challenges out there that customers are trying to solve, and it typically falls around, getting access to that data and bringing it up to the applications. And so from even our very beginning, we've been helping customers with hub and spoke architectures, right? Where you put those spokes out there to do local data collection, store and forward, and potentially have a local HMI as well on critical assets. And so when customers are looking at doing that, especially, trying to do this at scale, they're kind of getting those proof of concepts out there. And Raspberry Pis were just so easy to get a hold of and to try it out. And it really did, it worked. It solved the problems, right? But then there's that realization that we've got to have reliable, ruggedized, we've got to have the right hardware for the right solutions. And now we're kind of at that inflection point where we're going from POCs now to actual production systems, because they need to get access to more data. They need to do more with that, and that requires different architecture.
Right, makes sense. And Mike, to bring it back to sort of the birth of our hardware technology and solution, talk about crossing that bridge a little bit from that proof of concept makerspace place into a place where industrial hardware becomes a reality. What went into the design of our product to sort of bridge that gap?
Certainly. The fact that it was our first foray into ARM technology, that was really cool. Because as Travis alludes to, a lot of people are messing with this stuff, right? Using it for proof of concepts. A lot of our engineers use these at home for home automation. I think Travis might play around with that a little bit too. So as you can imagine, the line to be on this project was pretty long. And anytime you can get an engineering department that excited, it means you're probably going to get a pretty doggone good product out of it. For us too, the market position of Raspberry Pi was really important. Super, super great company, well-established, great hardware, great user base, great community support. We're thrilled to death to work with them. They're a fantastic partner. We're very proud we've been accepted into the Powered by Pi program, and we're participating in that. For us too, it gave us a lot of opportunity to do some different things. Still working with our existing customers in these spaces, but really, turning on some new additional interfaces, letting our existing customers do new things that we're not able to do before, as well as getting into new spaces. Talk with my lead engineer on this, Dave. We kind of had this philosophy, when in doubt, bring it out. And what I mean by that is if there was an interface on the Raspberry Pi compute module, and we thought it would be useful to our customers, we brought that out externally so that they could get access to it. So analog, in, digital in and out, thermocouples, current sense, voltage sense, we try to give as much flexibility as we could. And, what's really neat about that is because we brought out all these interfaces and kind of had a, let's see what happens sort of an attitude towards it. It's given our customers a chance to really experiment and see what works and see what the trade-offs are. And as well, here at OnLogic, we believe in, as they say, eating your own dog food. So we're deploying our factors in our building automation in our brand new facility. So we're kind of learning alongside our customers, and we're getting a lot of really good feedback from them. We're learning a lot from our experiences with building automation, and it's just helping us think about that next generation of product down the line and what we'll do with this thing. So it's just been a really neat journey.
That's awesome. Yeah, I actually had a chance to chat with Dave just yesterday, and he gave me a little early tour of some of the building automation stuff he's setting up at the Factor 202. So that's really exciting. And on the experimenting and playing with it side, Travis, Mike alluded to it a little earlier, but I understand that you do some home automation using the Factor series as well.
Yeah, absolutely. I'm really a big fan of home automation, a big enthusiast of it, and I like to connect everything in my house. And I know my wife's not so happy with it, but I like to get more of those devices and bring them in and get them all connected. And I use the device I have a lot of Z-Wave and Zigbee devices, so I have a USB stick plugs into it. I can get access to all of those, bring that data into Ignition. I'm using the Maker edition of Ignition to be able to see the data and visualize that around the house. I'm also, because I have the I/O, I'm able to connect to, for example, my hot water heater. And I can, for the recirculation pump, I can turn it on and off when we actually need it, rather than relying on a schedule. I can plug in a Google Coral stick to do real-time object and dog detection of the cameras I have around the house. And so it's really versatile, and it's easy for people to get access to, and they can do a lot of great things. And there's a lot of material out there, especially in the makerspace, to have a lot of fun. And I know I certainly have.
So cool. Yeah, I mean, one of the things that, as Mike said, trying to figure out what are the things that people need out of this device to do what they're trying to do. Mike, take us through a little bit of some of the other design considerations that go into making an industrial Raspberry Pi solution usable for those who need to use it.
I think the big switch is when you move out of that sort of prototyping phase, right? A lot of people just go up on Amazon, get a Raspberry Pi. I got one in my desk drawer at home that I play with from time to time. That's pretty cool. But man, you take something off of Amazon and you put it at, in a, energy situation out in an oil field, it's not going to survive, at least not for very long, right? So the first thing that you do is you industrialize. And we kind of spoke to that a little bit. So I won't go back over that same territory, but it's more than just the environmentals. It's EMC, it's regulatory compliance, right? These are major factors. For anybody who's done a project that's subject to regulatory compliance, that's something that you think about very upfront. And we did that, right? So we try to take as much of that off of our customers. So wide deployment, different countries, really try to hit a lot of the standards. So that makes it deployable. That's really the key. Second, there's other things that, you really don't think about. My Raspberry Pi has got a little power adapter. I plug it into the wall. You walk around, some of these instances, there's no AC plugs to be found. So, in vehicle, in trains, shop floors, you're probably going to put it on a DIN rail. That DIN rail has probably got 24 volt power. So we wanted to make sure that we were able to accept DC power coming off of a vehicle or off of a DIN rail, and make sure that, we would accept wide power, because a lot of the times it varies, what you have access to. But the heart of it was the CM4 module. And that's what really opened things up, is when Raspberry Pi developed an industrialized Raspberry Pi module, the CM4, that really gave us the heart, right? And then we built around that. There's things like, an M.2 drive. eMMC is great, right? A little slow, but man, if you're going to collect a lot of data, store a lot of data, do store and forward, do any sort of light analysis, anything like that, you find out that you need something robust like an M.2 SCADA drive. Connectivity in general, right? Wi-Fi is great. Ethernet is great. Travis, man, when we go out in the field, you look, some of these things are only available via cellular connection. So we've got a 4G LTE option so that people can get to their data. The days of sending somebody out on a 2-hour drive out to that wellhead to collect that information and drive on back to the office, those days have long passed. So just trying to think about how to make it deployable and useful and get that valuable data and get it back to the office where you can make use of it.
So great. And I think that that's part of what makes the partnership here so special. And one of the things I definitely want to touch on before I let you guys go is, what are those things that you're seeing people actually do with devices like this, with the Factor series and with industrial Raspberry Pis in general? Mike, get us started, and then we'll move to Travis on the inductive automation side. What are we seeing on the OnLogic side with folks actually building using the Factor series?
We're seeing a variety of use cases. The obvious ones, supported legacy equipment, connectivity to legacy equipment. The reality of the world today is there's a lot of existing stuff out there that works absolutely fine. Some of these old PLCs and sensors, they're not easy to replace, nor would you want to replace them. So you can drop in a small Factor, 200, and all of a sudden you can get remote access to that equipment. You can do some, data collection, maybe a little bit of lightweight data processing. All these things, protocol conversion, that allows you to not only get the access to it, but do something more useful with that data. Connectivity, we kind of talked about, cellular connection, things like that. So wherever it is, we can get to it. Whatever you need to do with it, we can do that too, and then get that back in a usable form. From there, we've seen viewing stations, we've seen HMIs, digital signage, all that kind of stuff. And of course, building automation, whether it's our customers or ourselves using it for the new facility. A lot of really, really cool use cases.
Anything in particular that's been a favorite of yours that you've seen come through?
Oh, man. I absolutely love the security company that we're working with. And to me, the cool thing about this use case that I'm going to describe to you is to show what you can do with limited power. This is a Raspberry Pi. This is not a Xeon processor. This is not server grade. This is not a $3,000, $5,000 unit where you're going to do AI. But you can do really neat stuff. So the security company that we're working with, they're using sensors to do very simple triggering of potential security events. So proximity detectors, door opening detectors, movement detectors, different things. They're capturing that image, they're capturing video, they're capturing audio, bringing that into the device, doing some simple processing, and then sending that up to the cloud where their people can then evaluate, is this truly a security event? Or did we just have a squirrel sneak into our facility and run across everybody's keyboards? And to me, that's really cool. Like, you get a really, really useful application with very simple technology. And that to me is the whole thing about, this data is becoming more and more valuable. That's really important to know that about your remote facility. And yet it's not costing you thousands of dollars to figure that out. It's down to the hundreds of dollars now. And that's why it's a tipping point.
Makes complete sense. And I know that, Travis, on your side of things, the inductive automation users, the ignition users out there, harnessing that data is really key to what everything that they're trying to do. Talk a little bit about what what excites folks in the ignition community about industrial Raspberry Pi devices.
Yeah, I think we should look at the kind of some of those use cases, some of the things that people have been solving for a long time. Historically, when we build a SCADA system, especially with ignition being unlimited, customers want to deploy a single server and they want to connect to all of their devices that are out there. They want to bring all that data in. Well, of course, they bring what's important, for the HMI, for what people, the operators need to run that facility. But even in there's certain industries where there's connectivity issues. I mean, of course, if I'm oil and gas or water, wastewater, I've got remote telemetry out there, so I could lose the connection to a remote site. Even within a manufacturing site, I could have different buildings. I mean, the forklift can cut the fiber to a building. And if your system was purely central, you could lose data, you could lose visibility, you could lose control, right? And so we, from the very beginning, kind of look at hub and spoke architectures. Now we kind of call it, we officially call it edge, right? And so the spokes are the edge. And we're putting something out there close to those devices so that we can eliminate some of these connectivity issues. We can connect that data locally. We can potentially pull data at faster rates. We can get that data to be sent up to a system more efficiently. We can, and this can scale more, right? We had scalability issues with just one centralized server, but now by distributing out our architecture, if you, there's a great diagram we can show here for the users that will kind of see where, I can figure out where we want to put these edge devices, but connect to that data locally, be able to deliver that information up, and really we can combat not only latency and connectivity issues, but data's gold, right? We need more of it, and a lot of people, analysts say there's like 90% of the data strand in the field. Well, this gives us the ability to connect to that data, bring it in, and democratize it, make it available to more places. And I think that's really, really key. So it's solving those challenges here. And at the same time, we can have a local HMI, on a critical asset. There's a lot of great use cases for it. And so it's kind of a no-brainer in like oil and gas, water, waste, so those remote telemetries. But in manufacturing, it's all about getting access to more data, being able to do more with that data. We're going to get into AI and ML now, right? Give that information up to the cloud, and we got to make that accessible. I'm even really excited about, just fleet management. We're seeing, like, as Mike said, right, seeing these devices on vehicles where they're now able to capture real-time data and have that stored and sent up through cellular, whatever means it might be. It's providing an avenue to solve these challenges, plus allow for the ability to do more. And having that local compute, there's more possibilities that it opens up architecturally. So I get really excited about these different use cases, and it's for customers, it's really solidifying, what they're trying to accomplish.
Awesome. Thank you for that. And, I'm hoping that other people, the folks watching us today, are also super excited. So I want to leave as much time as possible for questions. So I want to thank both of you gentlemen for joining me today for the conversation. And now I'm going to throw it to us in the future to go ahead and answer folks' questions live. And so thank you very much for joining us today. Thanks for talking Industrial Raspberry Pi. I'll see you and everyone watching in just a second. Thanks, guys.
Well, those guys had quite a lovely conversation. Mike, Travis, great to see you both again. Thanks for being here today so we can answer a few questions from viewers.
Thanks, Travis. It's great to see you as well.
Yeah, absolutely. So we're going to dive right into it. But for those of you watching, if you still have a burning question that you'd like to address, go ahead and drop it in the chat. We'll get to as many as we possibly can. Travis, let's start with you. So there was a question about data processing on Raspberry Pi devices like this. What are the possibilities there? What can users really do with this kind of device in terms of data processing?
Yeah, I mean, we did a lot of benchmarking with this type of device, and it's kind of get the sense of what is that upper limit? How much data can we process? How many devices can we connect to and bring in? Because it's important to understand from an architecture standpoint, right? If we have PLCs all throughout our factory or different sites remotely, we want to know, how many edge devices do I have to put out there in order to get access to all of that data, right? And so what's great about this device is it's not super constrained, right? It's when the first Raspberry Pi came out, right? It's single core, very limited memory, but this one has a lot more processing power with that CM4, right? It has a lot more memory available to it. So it opens up that possibility. And we're able to get tens of thousands of tags in with this in real time, polling at a second rate with values actually changing every second. We can connect to, probably up to 50 devices with this kind of compute instance. So the possibilities are really quite large. You can use it as one-to-one, but you could also clump a lot of devices together in that, in a single Pi device. So pretty exciting on that front. Plus, you also have the ability to leverage it for those local HMIs. You can easily launch a couple of clients, from there and let people, not only get that store and forward out there, but let people interact and play with that data and control that data. So I think that it opens up a lot of possibilities because there is quite a bit of compute that is available.
Yeah, so as Mike mentioned during the session there, limited power doesn't mean limited capabilities. So it's great to hear that there's so much that people can do. Mike, a couple of questions out there floating around about customization in terms of what can be specifically customized within the Factor device itself. Can you talk a little bit about that in terms of the other things that people can do and customize about the Factor series?
Yeah, absolutely. Happy to, Derek. Customization is something that we really pride ourselves on here at OnLogic. We give a lot of flexibility to the customer, even on our web interface, to select different drives, different memory, make sure that really fits the power that people need, as well as things like Wi-Fi and cellular. We talked about those use cases way out in the field. So, all of those sort of technical aspects we can absolutely support. The other thing that's really fun about the Factor is that we're able to do a lot of customization on the entire case. If you have a corporate brand color, you want a green Factor, we can absolutely do that. I think I've got a purple Factor floating around with one of my customers. So whether you're looking to brand any of our units, if you're looking to change the technical specs, that's something that we really try and work with customers. So I would just encourage, give us a call, tell us what your needs are, and we'll definitely work something out for you.
Nice. Yeah, that's really what we pride ourselves on here, right? Is trying to solve the problem for the customer, whatever that challenge happens to be. So another question here for Travis or Mike, jump in, whoever would like to answer this, but asking whether or not this only works with Ignition Edge or if other editions of Ignition are possible on the device.
It's a little bit of a trick question in a way. Sure, I'll jump in and then you come in after me if you want to put anything on top, Travis. So we're part of the onboard program with Ignition. And what that means is that we preload, pre-license these devices so that they can be drop shipped out to the field. And that's Ignition Edge in this case. So that's part of the onboard program. If a customer's got a license for full Ignition or wants to put Maker on it or anything else, they can do that, as well as putting on additional modules and things, all those great customizations that Ignition allows for. So yes, these will come already pre-licensed and pre-installed. Now, the other thing is that we've got a lot of computers that work really well as MQTT brokers or as Ignition gateways, all that kind of stuff. People can bring their own licenses that they get from Ignition, install those. Like I said, we've got a number of systems that really fit that bill well. So if you've got more general Ignition needs, again, I would just really encourage, give us a shout. We'll find the right system that'll fit your technical need.
Travis, anything to add there?
Yeah, like you said, I mean, either edition will work on the device. Typically, we're looking at these architectures and where we're putting them. It makes sense with the Ignition Edge product because it's really geared towards that local control. It's geared towards that store and forward of data, pushing it up through MQTT to a centralized system. It's what's designed for, right? So people are kind of thinking of it in that way. But if there are other use cases where a full edition of Ignition could be useful, it is also possible, and you could buy that license from us and deliver it to that, install it and deliver it on that device. So pretty easy to do.
Got it. Awesome. Something that there's a question here about UL certification. Is there an opportunity to UL certify the product? Mike, you want to talk to that?
Yeah, UL certification is actually something that we're talking about this week and trying to expand the offerings there. I can't tell you right off the top of my head, where we stand on this product, but again, that's something I would really encourage somebody to reach out to us and talk through your needs. But yes, in general, OnLogic really takes UL certification very seriously. And we try and come up with as many pre-configured options as we can to make that UL process very, very simple for folks.
Yeah, and that's one thing I definitely want to reiterate. Reach out to the team, find out, what's going on, what the current status is. That's really an important part of what we do, is making sure that we're having those conversations in terms of current state. We had a couple of questions about LoRa, creating a LoRa device here. Mike, any comments there around a LoRa gateway in the future somewhere?
Yeah, absolutely. And I see another question came in, so I'll probably just hit both of them at the same time.
Great,
so love LoRa. We do get some requests for it. I'm actually partnered up with Semtech. We're looking at some options. I can't promise an exact rollout, but I definitely take that feedback very seriously, and it is something that we're looking at for future path. So if anybody has got any specifics that they want to send to me, connect with us here, get that passed through sales. I'll make sure that we take all those sorts of needs into account as we select that LoRa card. And as well, asking about modularity and hats and things like that. Hats are really interesting. We could probably spend a whole lot of time talking about hat usage, but modularity is something that we're absolutely talking about, and that will probably be in the next generation or the generation after that. Again, we're trying to figure out what is the right packaging. And the more input that we get from our customers, the more use cases that we see out there in the field, because we do want to keep the price point very, very effective on this thing, and design the right combination of modularity and standard features. But yes, it is absolutely in our plan of record, just trying to figure out exactly how we want to do it.
Got it. Appreciate that. Thank you very much. So there was a question here, Travis, you mentioned benchmarks. Any way that you can elaborate there in terms of what kind of benchmarking has been done by your team on these devices?
Yeah, so specifically the benchmarks that we did were, we always kind of do worst case testing. So we look at, and usually it's around number of tags. And so we'll start with, say, 500 tags at a 1 second rate, pulling from a PLC. And so we will connect to a real PLC. We don't want it to be a simulated value, because that's not a real world scenario. So we'll connect to typically Modbus devices, and we'll pull those values every second, and we ensure those values are changing every second in that device. And the deadband ignition is going to be 0, because we want to process those changes on every single one of them. So we start with 500, kind of do that, see what the CPU memory footprint looks like. Then we'll go add another 500, or it might do 1,000 at a time. And so we keep doing that. And we basically, build a spreadsheet up where we can see what's the upper limit. At what point does it start? Does our CPU start, pegging, or do we, not have enough memory available to do those? And in this particular, with a traditional kind of more constrained, one of the earlier versions of Raspberry Pis, we would only get up to around 1,000 to 5,000 tags. I mean, it was a very small range. Here, we were easily able to get up to, specifically in the benchmark that we did, 20,000 tags, all pulling every second, with values changing every second. So it's pretty exciting, and that was being sent up through MQTT with the benchmark there. And we have the actual results, so we can share with folks. If there's any interest, we can send that out.
Awesome. Thank you for that. Cool. Appreciate it. So one more question here. Can I use the device with Ignition Edge to simulate a Modbus device? Travis, you want to take that one?
Yeah, so I'll start there. I mean, in terms of Ignition, our Modbus driver is a client driver. So we're going to connect to a Modbus device, and we're going to go and ask it, send those commands to ask for that data and pull it, very frequently. We are not a Modbus server, and that we're not listening on that port. So it's not like they can connect to us and ask for that data. So we can't do it that way, but we can certainly simulate a Modbus device with an Ignition, in terms of we can, build out the tags with the right, naming structures and all that. So if you switch it to a real PLC, that it will still work with those tags. But we are not a server on that. Right. There's plenty of really good simulators though you can use. Modbus simulators that are out there, like ModRSim and others, that you could use on the same device or different device, and that would typically fit the bill.
Gotcha. Appreciate that. So a question here around a network with a Pi module sort of in place there. Would it need to be isolated behind a firewall? Mike, I don't know if you've got anything there to share, or Travis, if you've got any thoughts there around security as it relates to the Pi module.
Yeah, I think on that one, let's really talk about, you know, the architecture that you're in and also the software that you're running on the Pi, right? Let's look at the whole security picture, and that's something our sales engineers can really help with.
So it's really about understanding the whole architecture of the network to understand where that plays in. Travis, sorry to interrupt.
Yeah, and I'll just elaborate a little bit in that, you know, it's very, we're talking about edge a lot these days, and we're talking about being able to bring data up typically to business systems, and leveraging MQTT is a good example of how people are doing that. So one thing that's really great about an edge device, if we look at a traditional SCADA system, to put it centrally, we're going to have to, it's typically on layer 3 on that network where all the PLCs are. We have to have, you know, it has to be able to talk to those in that network, to all those devices. So, you know, if I were a bad actor who was able to get on that network, I could discover all those PLCs, right? And I could do potentially harm. So it's not necessarily about people kind of hacking the network. It's about more of like USB devices that get plugged into a computer that's on that network. We look at security. So what's great about an edge device is you actually are putting it in front of that PLC. And in this case, we got, you know, dual network interfaces where we can have one that talks to the device locally, and then one that goes push that data up to a business network. And so when you look at MQTT, it could be a secure TLS connection outbound only. There's no ports coming in. And so you actually get a much stronger security footprint than you would have before. So, you know, obviously IT departments can do a lot with firewalls and all of that, but I kind of think of edge as another layer that really helps with that security posture.
It's a great call. Thank you for that. Further clarity, appreciate it. So what PLC brands could connect with OnLogic devices in order to get data extracted and send it to Ignition for further visualization and analytics work? So talking about what can you connect to a factory device? Mike, talk a little bit about that.
Yeah, I'm actually going to throw that over to Travis because this is all module based, as I remember, Travis. And Alan Bradley, I'm trying to remember what all is in the Ignition ecosystem.
Yeah, so Ignition Edge has all the drivers built into it to talk to these different PLCs. You know, all the Allen Bradley Ethernet suite of devices, Modbus Ethernet and Modbus Serial is supported. Siemens S7 devices, BACnet, DMP3, Omron NJ and CJ. We just released a 61850 driver that's out there. We're working on a Mitsubishi one. There's a really good set of drivers that are available. And you can also, if I'm not mistaken, for your side there, Mike, you have the I/O on the device, and that you can connect direct, you know, analog or discrete values, and then we can bring that into Ignition and have that being published up.
Absolutely.
Yeah. Good one. Okay, so any comments on use for local HMI performance response, mainly along with MQTT tag transmission?
Yeah, so I would assume it's talking about them being together, and that we're sending data up through MQTT transmission, and then you know, along with that, what's that local HMI performance look like? And so, I mean, again, that it goes to you know, if you're pushing the boundaries of just sending the data up through MQTT, if you've got, let's say, you know, 100,000 tags, they're changing quite fast, you know, you may not have enough. You may not have enough room to run a client, or a client could look slow if you're pegging that computer. But overall, typically we don't see that with this. The HMI performance is immediate, sub-second, it's right there, it's local, and then that data is also being sent up, and so you kind of get the best of both worlds: the local control and a stored forward of data, and we're seeing a lot more of that, especially nowadays when it's hard. I know there's a question on supply chain. We can get to that, but it's been hard with other HMI products to be able to get them if an HMI dies. And so it's actually very easy to then put this in with Ignition and have a local HMI replacing some of the traditional ones, and you get that benefit plus other benefits. So it's a big win-win.
Nice, appreciate that. Let's see, has it been tested with a Pi-based YATO build?
We support Raspberry and we support Ubuntu. We find working with Ignition, most folks are on an Ubuntu build. So that's primarily what we focus on. YATO should work. And certainly if you want to try that, we've got a try OnLogic program where you can work with sales to get a sample unit sent out to you, and then you can experiment around. And that's just a conversation to have with our folks.
From an Ignition side, the YATO build, it will work perfectly fine.
Nice. And then that's the question you were referencing there, Travis. It's been challenging to get Raspberry Pis recently. Question around how we're able to keep these in stock. Mike, I'm sure you can speak to that.
Yeah, absolutely. And I hear this person loud and clear. It was hard for me to get the one that I play around with at home, but that's a consumer one. So we've got a few things that really help us out here. One, it's a CM4, and that's a completely different unit, right? These are the industrialized ones, obviously not a consumer grade. So it's a completely different supply chain for that in a lot of ways. Second, we've got a really good partnership with Raspberry Pi. They're absolutely awesome to work with. They really work with us with availability and allocations and things like that. So they've been very, very supportive of us. And then lastly, I've got such a good supply chain here. They all got so good at their jobs as we went through COVID and supply chain, and that skill set is just kind of carried on. One thing that we really, kind of point to in terms of working with OnLogic is we've got very good availability and we've got very reasonable lead times compared to everybody else. So it's just something that we're proud of. And we've got very good availability on our factory devices today.
Awesome. Appreciate that. One more question coming in here. What about ESP32 using like data collector instead of a PLC? Any comment there on that, Travis? ESP32?
So I am not familiar. I think the ESP32 is a like an MCU, but I'm not 100% sure in terms of that one there. Mike, you have?
No, I'm not familiar with that either, Travis.
If you can clarify a little more, Omar, in terms of the question, we can maybe we have an answer for you.
Yeah, and that gives us the opportunity to say if there's anything we don't get to chat with about today, feel free to reach out to our team. Feel free to reach out to Inductive Automation, Travis's team there, to talk more about exactly what you're trying to do, because ultimately it all comes down to being able to fit the device and the software to your application, your use case. With that, we're already over time, so thank you everybody for all of the questions. We really appreciate that. Mike, Travis, thank you so much for joining us once again today. Really exciting conversation today and really appreciate it. Thank you everyone who watched for joining us for OnLogic Live, and we'll see you next time on OnLogic Live. Thanks again, guys. Appreciate it.
Thank you.
Take care.